Good evening or good morning, everyone, depending on where you're joining us from. Welcome to STEM to the Sky's first speaker panel of 2023, yay. So this one is called Careers in Space, a Universe of Opportunities, and the event will be centered around the space industry, and we're really excited to have 4 amazing professionals in the field joining us today to share their experiences. So to introduce myself, my name is Eileen, and I'm a senior from Maryland. I'm also one of the co-founders of STEM to the Sky. Annie, our other co-founder, should be joining us shortly, but I can pass it on to Anaga to introduce herself.
Hi everyone, my name is Anaga and I'm a high school junior from Maryland. I'm the International Marketing and Outreach Director here at STEM to the Sky, and I'll be co-hosting today's speaker panel. Thank you all for joining us here today.
Hi, my name is Sasha. I'm the other co-host of today's event. I'm a member of the Marketing and Outreach team as well as the Content Development team. I'm a high school senior at an international school in Japan, and I'm very excited to get this speaker panel started. Thank you to everyone who's here today.
And a special thank you to our panelists, Dr. Miller, Dr. Chirenti, Dr. Edwards, and Beth Weinstein, who will be sharing their experiences and wonderful insights with us today. So today's event aims to share the experiences and advice of professors and research scientists in the space field, as well as to inspire our audience's interest for space and possibly careers in the space industry. Everyone in the audience will have the opportunity to ask questions about space and our panelists' experiences with pursuing this fascinating field. We are very excited to have Dr. Cole Miller, Dr. Cecilia Chirenti, Dr. Louise Edwards, and Beth Weinstein here with us today to share their knowledge and experiences with space science.
So here is an overview of today's event. First, we'll have Eileen briefly introduce STEM to the Sky. Then our 4 amazing panelists will introduce themselves and they will give a general overview of their background and careers. Then we will transition into the main part of the event, which is the Q&A and discussion. And using the topics and questions all of you have provided from the event RSVP form, the panelists will offer deeper insights into what pursuing a career in the space industry is really all about. Then we will open up the floor to any live questions that any of you may have.
And to wrap up the event, we will share our panelists' contact information in case you want to reach out with any further questions. We will also discuss how you can get involved with STEM to the Sky. I'll now be handing it over to Eileen, who will explain more about STEM to the Sky.
Thanks, Anaga. So STEM to the Sky is a nonprofit organization founded in 2020. So it's based out of Maryland, but we have members from all over the world. There's kind of 2 pillars to our mission. One is to showcase diverse careers and faces in STEM through interviews, and the other is to advocate for a more equitable STEM community through these interviews. And we also have several other initiatives like the speaker panels that you're attending right now. We also do community engagement, both locally and internationally. And we're really excited to push out several other initiatives too in the new year. And we also have a monthly newsletter, which I can explain a little bit more at the end of the panel, but that's a little bit about STEM to the Sky. And I think there's some more statistics on the next slide. Awesome. Yeah, so we have over 30 team members, which is really exciting, ranging from all different countries around the world. We've featured over 30 professionals in our interviews, and we've reached, I think now, over 78 countries, which is really exciting, and 300 schools around the world.
All right, and finally, passing it on to our panel for today, we are very excited to introduce the 4 panelists. So we have Dr. Cole Millers, and we have Cecilia, we have Dr. Louise Edwards, and we have Beth Weinstein. They are actually, as we found out, are pretty familiar with each other and each other's work. So this is a big change of pace from what we've usually seen in our past speaker panels. Usually our panelists don't really know much about each other, but this time it seems that our panelists might actually have quite a bit to talk about. So handing it off to Anaga.
Without further ado, please welcome Dr. Louise Edwards, Assistant Professor of Physics at Cal Poly SLO, who will start us off.
Hi, everybody. So San Luis Obispo, where I'm based, it's in California on the coast. So if you can imagine where San Francisco and LA is, we're right in the middle of those two. It's a beautiful area. Here at Cal Poly San Luis Obispo, we're a polytechnic, so that means we specialize in things like engineering. We have a huge aerospace, and likewise, our physics department is a huge department, and we have several astronomers. So I'm one of them. I'm an observational astronomer. I specialize in multi-wavelength observations. So anything from the X-ray all the way down to radio, but most of my work is in the infrared, like this beautiful picture from JWST, not my work, but beautiful, and in the optical. So like those are the wavelengths you can see with your eyes. My subject area specialty is the largest objects in the universe. They're called brightest cluster galaxies. Here's an example of one, the thing that's right in the middle of that beautiful image. And also I've started something new this last year and a half, which is helping to get a new telescope up off the ground, not physically off the ground. It's not a space telescope, it's a ground-based telescope, but getting it finished and tested and working. It's called the Rubin Observatory. It's located in Chile, but it's a Chilean-American partnership. And this is a picture of the observatory housing. Notice you'll see like a car, it's a truck in that image by a door. That gives you some context for how humongous that observatory is. And the camera that goes on the observatory is that shiny thing in the middle picture. And I was lucky enough last summer to get to help test how that camera is working. So that's been really exciting for me. So that's it. I am an observational astronomer, and I think the last slide shows a bunch of my students. One of my most favorite things to do is to interact with the undergraduates here at Cal Poly. We're an undergraduate serving institution. So these are a few of the 40 or 50 students I've worked with over the last 6 or 7 years. And my daughter in the stroller, and my son still in the belly. Now he's 3.
Thank you, Dr. Edwards. It was really interesting to hear about one of the current projects, I guess, that are being worked on in the space industry. Now we'd like to welcome Beth Weinstein, an Observatory Manager for the PACE mission at NASA.
Hi, everyone. So I've been at NASA for over 20 years, and I've had, I think, 5 or 6 careers just at NASA alone. So just letting you know that there's a variety of things to do at NASA. I started off because I was a computer science major. NASA has many satellites that we have built and launched that study the Earth. And they create a lot of data. And so NASA has data information systems that store that data and also help people use the data. So that's kind of where I got my foot in the door at NASA. And through that, I was able to work with other space agencies. So countries all around the world have their own space agencies. They have their own Earth science, Earth observing satellites. They have their own data. And so we were working together in order to make sure everyone could use their data, try to figure out similar formats, try to make sure we weren't overlapping too much. So we were really, space is really an international endeavor. But from there, after a few years of doing that, I decided I really wanted to learn how we built satellites, and NASA is a great place where if you ask for something, show a little hard work, they let you try something new. So I started getting into building satellites, integrating them, testing them, and many of the satellites that I worked on have launched also. And one of them that I worked on, we actually launched from Japan, Tanegashima, that's the picture on the right. And one of the ones I'm working on now, I'm the observatory manager, which means I'm in charge of the spacecraft portion, everything except for the instruments that actually take data. So I have a thermal, mechanical, propulsion, guidance, navigation, and control engineers. Everyone kind of works together in order to, decide what we're building, design it, procure the items, build some items, even at NASA, put it all together and test it. And then we're going to launch this mission in about a year. So that's the picture kind of on the bottom is from a little while ago from within the clean room. But also during this time, I kind of had an interest in policy. NASA headquarters is based in Washington, D.C. And what policy is not only kind of creating a message for the agency, but also deciding where the agency is going to go. And so I was lucky enough that NASA paid for my master's degree in policy, and I was able to do a short assignment at NASA headquarters as well, where I wrote talking points for the agency for upcoming missions. I wrote testimony for hearings with Congress. I helped create budget profiles that went to the Office of Management and Budget to decide kind of where we were going to put the money. So that was another thing that I worked on. And then most recently, I was accepted into a fellowship where in July, I'll be working in Japan for a year at the Japanese Space Agency. So it's called the Mansfield Fellowship. It's open to people that work within the government. So it's not just a NASA thing, but everyone works at their sister agency. So that's just a little bit about me.
Thank you, Beth. For our next panelist, we would like to have Dr. Cole Miller, who is the professor of astronomy at the University of Maryland.
Hi, everyone. Thanks for joining us. Yes, I am a professor of astronomy at the University of Maryland. In contrast to Louise, who does observational work, I am a theorist. You would not want to let me too close to a telescope, but I try to understand the inner workings of things like black holes, neutron stars, gravitational waves. And one of the things that I find to be fascinating about the field is that it does allow you to travel a lot. I haven't traveled as much as Beth has. I've only been to, I think, 37 countries instead of her 50, but it's a great way to understand other people, to be the foreigner in different countries. And I have a few photos from there. I grew up in a rural area of Michigan. Fortunately for me, my parents are both public school teachers who valued education. So I went to a local college for my undergraduate work. Then I went to graduate school in Southern California. And then after a couple of other stops, I started at the University of Maryland in 1999. And it's really been remarkable. It's a fascinating field to be in. I feel very privileged to be able to do this for a living. And I also enjoy teaching. And if we can see the next slide. I have a few other items that I like to do because I feel that it is important to have a full life. You don't want to completely subsume yourself in your research, even though that is fascinating by itself. And so I have a few items that like here that indicate what I like to do for fun.
Thank you very much, Cole. I think it's completely true that you need to make sure you have a full life, and hearing that even though your profession is so demanding, you have time for travel. Now for our final panelist, we would like to welcome research scientist Cecilia Chirenti.
Hi. So yeah, I'm originally from Brazil, from São Paulo in the southeast of Brazil, and that's where I went to school. I did my undergraduate studies, where I got my PhD, and then from there I decided that I had to run away, and I went to do my one postdoc in Germany, and I came back to Brazil to become a professor at a new university, which is one of the 2 schools in the country to have an airspace engineering course. That one is very popular. And there I have had the opportunity to work with lots and lots and lots of undergrads. And I've been in Maryland as a research scientist since the beginning of 2020. I'm associated with the astronomy department of the University of Maryland, but I actually do work at NASA Goddard as well. But Beth and I have never met there, I think. It's a big place. I do work that is probably the most theoretical of the bunch here, more towards physics and mathematics, but which can be applied to astrophysics. And in recent work that I've been doing at Goddard, I have not been involved with exciting new missions, but I have actually been working with really old data from the 90s, where we have been able to find exciting new features. And this is probably older than most of the people participating here in this panel. But yes, with technology from the 90s, we were able, or NASA was able to record exquisite data, where in our work, we were able to find hints of amazing things like hypermassive stars spinning like the fastest things in the universe. And I'm very excited about that. And here the photos are just a little bit of things that I like. And in the bottom left, you can see a photo from one of the ballet classes I was taking in São Paulo. I'm there at 7 o'clock on this photo. And it's the last time that I was taking any ballet classes was in 2020. And I got kind of tired of doing that in the kitchen because the ballet studio was closed. So I'm still thinking whether I'm going to go back to those classes or not. And I'm excited to be here and talk with you. Oh, I had another slide. Sorry, I forgot. More stuff that I like. Yes, of course, going to the beach, bird watching, and I have actually found a way to deal with the squirrels raiding my bird feeders. I'm very proud of that one.
Thank you, Cecilia. I'm so glad you found a way to get rid of the squirrels. And thank you to all of the panelists for sharing your insights with us.
Awesome. So now we're going to transition to the most anticipated part of today's event, the panel discussion and Q&A.
Before we open up the live questions, we would like to ask the panelists some of our most frequently asked questions from the RSVP form. And panelists, feel free to piggyback off of each other's answers.
I think, Sanhyun, if you could stop screen sharing now, that would be good. Awesome, thank you. And I'm gonna
All right, so for our first question, starting off really simple, what inspired you to pursue a career in space? And any of you can feel free to just hop in and start.
I'll start. Actually, it was a class that I took in high school at Montgomery Blair High School. It was a remote sensing class. And I guess I maybe didn't really think about what you could do from space. I know a lot of people and my other panelists look at space from space, but I've always been interested in looking at the Earth from space. And I learned things like urban planning or archaeology or looking for ways, to find fresh water availability. So I think just taking that remote sensing course in high school really made me look at the Earth and space a different way and kind of led me to the path that I'm on today.
Really cool. For me, I had no plans to have this career. I was very curious about science and math. I just loved it in high school. And I devoured a lot of science fiction. And when I was thinking about what I wanted to study later on, I remember thinking like, oh man, it would be cool to know for sure, like whether or not photon torpedoes from, Star Trek or whatever are real or not real or could happen, but we're not there yet. Or like quantum physics, is that real or is that also, a science fiction thing? Yeah, nice. So that's sort of what it was for me. I just really had of a passion to learn. And in particular, I thought that physics was something that would be easier to learn with a group of people and, folks mentoring me. And so just kept on going with it.
Well, Star Trek fan over here, I have to admit that. The school system in Brazil works a little bit differently than here. So we need to pick our major when we are applying to college. So I was thinking about that and I decided that, well, among different possibilities, I don't know if you can make a career out of it, but I'm going to study physics because that's what I'm fascinated about. And I was really into the whole idea of curved space-time. I found it beautiful, right? And little did I know that it would take a while to understand that. But that's really what I wanted to study. So when I was an undergrad, I started learning about that. But curiously, although it's space-time, it is all about space, right? I wasn't so much thinking about it in terms of astronomy or astrophysics or actual space. I was more thinking about it in terms of the geometry of the curved space-time. And that's what was more interesting for me. And that's how I continued during my PhD and my postdoc and back as a professor in Brazil. And even one day there was this opportunity that I could submit an application to NASA to work on a project. and I had to put it in the context of one of their missions and their data. And I got in, I was selected. It was awesome, right? And then I was telling everyone that I'm going to work at NASA, and that's amazing. And people were asking me, Cecilia, we're so happy for you, but what are you going to do there? And like, oh, okay, I'll take that as just curiosity, and I'm not going to be offended, because I couldn't quite believe it myself. But what I was going to do there was basically the same research thing that I was doing before, but applied to the NASA missions. And for me, it was quite a revelation that this was something that could be done, right? That my mathematical background and tools and stuff could be applied there. So that was a different way to start working with actual real space and not just geometric space.
In my case, I was always interested in math and science. When I went to school as an undergrad, I was a math major, pure and simple, but it was a tiny school which only had 2 math professors, and I ran out of math classes very rapidly. So I decided to take physics just for the heck of it and started to appreciate the application to the real universe. And therefore, I went to physics graduate school, where I kind of wandered almost by accident into astrophysics. And something about astrophysics that some people here can appreciate is that the thing is, you're studying very distant things. You cannot put stars in a laboratory, fortunately, probably for humanity, which means that you are always having to simplify. You can't do it right. And this really bugged me for a while, because I was used to the rigorous proof of mathematics, and I didn't want to deal with any stupid approximations. But eventually I got to appreciate the art of astrophysics, where you take an inherently very complex situation and you distill it to its essence. And a standard joke about this for people who have taken calculus is that, again, I go from mathematics and rigorous proof to astrophysics, where I cancel the d's and derivatives. And at some point, this is something that has appealed to me, and I try to represent that when I teach. Although there have been times when I've canceled the d's and derivatives and gotten looks of horrified betrayal from the students.
All right, thank you guys for your answers. I think it's really cool how you guys had such different backgrounds and still ended up having a similar love for physics and space. So the next question would be, what does the typical workday look like for you, and what is your favorite part of your job? And how do you find a balance between your work life and social life?
So my typical day is a lot of problem solving. You know, every day is different and every problem's different. Some problems are technical, some are costs, some are schedule, but every day there's something new that comes up that we as a team have to solve together. And I do want to emphasize the team. Although I'm a manager in my title, it's really a team effort, space in general, and certainly any mission that you would work on. And I'm sure my colleagues here also work with a lot of people as well. So it's really, and that comes down to meetings, unfortunately, but meetings are good. They're a good way for, you really want to get different opinions from different people, not only because they're from different disciplines and they might have, you know, you might not be thinking in terms of their expertise in their discipline, but also just coming from different experiences. We come from different missions. They might have had a different way of thinking about or doing something. So, so really my day is working with people all day long, trying to solve whatever the latest problem is and making sure that we are doing things efficiently and can launch on time and keep all the science intact that we had originally planned. So that's what my day, oh, and work-life balance. That is difficult, but I will say, I mean, maybe this is bad, but I have a work phone, and that actually allows me to have more of a work-life balance, because then I can leave work to go have dinner with friends or be with my family, but I can still, for a second, if someone really needs to get in touch with me for some reason, or I need to do something, I still have that ability to kind of check in. I know that might not be a great answer, but definitely I think that it's incredibly important to have a work-life balance. And another thing is to trust your team. You know, at some point, I know you want to feel like you have to be there every second of the day and making sure, but, you know, trusting them, checking in every once in a while, but knowing that that your team, that you've kind of set them up for success, allows you to have more of a work-life balance.
I also have days that are different day to day, but let's say in general, over the course of a week, I would probably spend, you know, roughly 9 hours in the classroom teaching classes. And then a bunch of time before that, preparing the classes, and sometime, you know, doing assessments and stuff like that, office hours, all that kind of thing. So big teaching component, which I love and is, you know, the reason I'm at teaching focused university, undergraduate focused university. And then the other big chunk of my time, which kind of only happens more in the summer when I'm teaching less, is research with the undergraduate students. So there's sort of like the teaching component, and then there's the research component where we're working on the data together, where that mostly looks like coding actually these days. And then after that, the other responsibility that I have is what we call administration. So this is meetings and making sure that the university is functioning well, or the telescope teams that I'm a part of are, you know, working well, that kind of thing. I actually really like all three of the components, including the admin. In my own personal path, here, there was a lot of solo work. Like a lot of the research that I did, honestly, was just me for years. And there would be definitely days where I would come to the computer and just me and the computer all day long. That was not rare. So I really enjoy, now that I'm here, being able to have that human connection in research, in teaching, and actually even in, you know, trying to make the university a better place together in administration. So work-life balance, I love what I do. So honestly, I don't think about it as work. So I'm not suggesting everybody should be like that. Everybody can do their own work-life balance the way they want. For me, I love doing this stuff. I'm here on a Saturday, my own volition, because I love talking about this stuff. I do have a family, so it's not, I don't only do research. I showed you my kids before, they're 3 and 6 now. So the other big chunk of my life is having that family time with my little kids. And I get a lot of it. It's a very flexible job, so it's really nice.
Okay, so for me, my workday, of course, also depends on the day of the week. And now that I'm here, I'm not teaching. I was doing quite a lot of that in Brazil. And I did like it a lot. I would have liked it even more if I could teach less. So that's one thing that's for sure. And here there are lots of Zooms or Teams meeting, also with my graduate students that are still in Brazil or in Argentina. So there's a lot of time that I spend on video calls with my students, trying to help them with their projects. There is a lot of reading and proofreading of papers and proposals and that kind of stuff. Feels like there is more time spent in preparing things for publication and for submission than actually doing the work that goes into those results. It's quite interesting. So yeah, it's important to be able to write clearly and convey your ideas and convince people of your ideas. What else? There is some coding. There is a lot of plotting and making pretty figures, pretty plots for papers and proposals. There are meetings in person now. It's great to be back at Goddard and talking with people and meeting people, because I was there for about a month, and then we were told to shut everything down, go home and start working from home for 2 years. So that was not the best way to start a new job. Work-life balance. I love the work that I do, but I also love to do other things as well. So it's not hard for me to say, okay, enough. Now I want to play the piano. now I want to cook something nice, or I want to go out and hike. I want to do gardening, right? I have flower boxes. It's not really very extensive, but I like to do all of those things, and time is finite, right? So I have to stop work somewhere and have time for my other things. So of course, every now and then you really have to get something done. You have a deadline, something is late, most often than not because somebody else was late, but it happens, and then you do what you have to do. But yeah, work-life balance is important, and I really try to make room for the things that I love to do besides my work.
And for me, I'd like to follow on and agree with Louise. When you divide academic tasks, the divisions are all often into research, teaching, and service. Service is basically being on committees and doing the administrative work in various levels for your department, for the university, for the community that is necessary for things to go. Most of the time, I'm not especially into the service, but it has to be done, and I do my best. I love research. I love teaching. So a typical day will depend on what I'm teaching, how much I'm teaching, whether I have meetings with students, because the research can be conducted with students, with colleagues, by myself. And an aspect of that is that it is important, I think, to keep yourself fresh. And luckily in astronomy and astrophysics and a growing number of fields, there's an archive where you have papers which appear every weekday, and you can learn about the latest research. And it won't all be interesting to you, but it's something which can stimulate your imagination. In terms of work-life balance, it's critical to have. And the thing is, I sometimes tell my students, when it comes to getting a PhD, you're not given a PhD because you're an obedient robot for your advisor. You get a PhD because you have contributed creatively to the sum of human knowledge. And for that, you have to be able to have a refresher of your mind. It's a marathon, not a sprint. So if you're just going all the time, you will not be successful. So my line about this is that even if the only thing you want to do is be the finest scientist possible, you do not care about hobbies, friends, hygiene. It is nonetheless important for you to be able to have a balanced life. So in my case, what I try to do is be as efficient as I can at work so that I have the opportunity to exercise, to go places, to watch a movie with Cecilia, whatever it is. And this is something that keeps me more creative and, more importantly, happier.
All right, thank you. That was really insightful. I think it's really great to hear that you can always find work-life balance, and it differs from person to person. I feel like a lot of young people, especially at this age when we're trying to choose what to do with our life, what your free time will look like is quite an important factor. At least I know for me, that was something that I considered when applying to university. But for our next question, this is a bit of a loaded question. What do you wish you would have known before starting your career? Do you have any particular tips for students, and so like courses or internships you wish you would have taken that you think would have been really helpful, or something that you did take and you thought it was great and really good to start your career?
You know, historically, I think to be an astronomer, a lot of folks would say a real strong math and physics background is critical. And I think, you know, there's definitely that's a common way, the most common way to get into the field. But actually these days, you know, things are, somebody was talking about how, Beth, we were talking about how everything happens with these humongous teams. And these days I know folks who are active, amazing observational astronomers who come through all sorts of different things, like kind of through data science or through computing or through pure math, or, you know, the most common way would be physics. And at first, you know, to be an astronomer, a lot of my colleagues, you know, the undergrad degree wasn't in astronomy. You know, you learn all that kind of stuff in your graduate work or even in your postdoctoral work. So there's a lot of really different paths you can kind of take for the job that I'm doing in particular. So I'm at like there's different types of universities, and the kind that I'm at is a teaching focused university. So the kind of advice that I would give is going to be different than the advice that somebody would give at like a UCLA or Caltech or something that's a real like research focused kind of institution. So I think what I'm trying to say is follow your passion, you know, and do what it is that you love. Like, I don't think for me, it would have worked out to have worked for a very long time on a set track to do a specific thing. That's just not what happened for me. For me, I was enjoying learning the material kind of for the material's sake. And through that, you know, ended up doing this internship or that. And it was a very like, you know, random walk process to end up where I am. That's just my own personal path. But I would say, you know, as long, you know, yeah, you know, we don't need that. Nobody needs to be an observational astronomer. So if you love it, do it. And that should be the reason that you do it. And then other than that, I would tell myself to calm down and enjoy the moment. And for me, it was really important to, you know, I was really worried about, I didn't see a lot of women in the role that I am in right now. There's more now, but I didn't see a lot of that. And I was really worried that I picked something that would negate what I really wanted to do with my life, which was be a mom. And it took a long time. I'm 44, you know, so I had my first kid in my late 30s, and I watched my high school friends, my college friends, my grad school friends, my postdoc friends, everybody get married and have kids way before me. And it caused me a lot of stress. And I wish that I had taken a deep breath and calmed down and known that it's okay to do it later in life. It can still happen.
I mean, I do think, I mean, kind of agree with everything that Louise, that you said. I mean, certainly, I think having a STEM background is important, having a degree in one of those areas. But yeah, as you said, what I've kind of found is, at least at NASA, it's a lot of on-the-job training. And, you know, you need to have some kind of background like that. But in terms of, you know, the tools are here and the people are here in order to teach you the way you use those tools. And so, and there's always the opportunity to go back and learn. I think that, you know, just never stop learning or having that yearn to learn and grow. And the other thing I would say is that if you're interested in something, kind of tell as many people as possible, or find the person that's doing that thing, and don't be afraid, even if they're, you know, 3 steps up in the hierarchy, or they're, you know, I've gone to, you know, kind of cold called people at headquarters, or, you know, someone that was a project manager, you know, years ago, and just said, hey, I kind of see myself going there. What would you recommend? You know, and as you know, as Louise said, everyone had different paths, but still, you know, you kind of get an idea of, you know, what they needed to get to that job, or what they thought was important. And it also kind of puts you on their radar as someone that wants to do that in the future, and something that they think about. So just kind of don't be afraid to kind of to talk to people about what you want. And people are really receptive. I think, you know, certainly at NASA, if you reach out to anyone, they're really kind of open to talking to you about what they do or what you want to do, and try to help you get there. So just don't be afraid to ask for it.
Yeah, I guess that I agree with everything here. And one thing that maybe I can add is that we do it because we love it, because there are lots of easier paths that one can take. Nobody's doing this kind of things. Nobody's, for example, pursuing a PhD in physics because they thought it was going to be easy. Nobody said it was going to be easy. It is not easy. There are some tears along the way. But it is important to keep learning. It's important to take as many classes as you reasonably can, because everything is easier to learn if you sit in class and you take notes and you solve the problem sets and you talk with the professor and you study for the exams. You can absolutely learn things on the job later on, but if you have like this glaring gap in your background, that becomes more complicated. Relative to that, learn statistics. I speak from experience. And I started working with gravitational waves when gravitational waves were a thing of the future that maybe one day will come, right? And I sometimes open my talk saying, I can say anything I want because there is no data to contradict me. And now there is data, and if there is data, that means that you need to know how to do data analysis. You need to understand the statistics and systematics and all that stuff. So that's just one advice that I would have given myself back in the day. Please take statistics a little bit more seriously. And you're going to find lots of people that are very supportive. You're going to find people who are not super supportive, but can still be supportive. The person who became my PhD advisor, I went to talk with him for the first time when I was in my second year. And he told me to basically go and study a bunch of stuff and then come back. And I did come back. I had not properly studied every single thing that he told me to, but I did come back. And things proceeded from there. So it's if it is what you want to do and you want to put in the effort, it's not going to be easy, but we do it because we love it. And yeah, and learn statistics.
Following on from some of this, I would say, don't be afraid to fail. In research, we're doing things that people haven't done before, otherwise we couldn't publish it. In that sense, I fail most of the time. It's not like I enjoy failing exactly, but it's an opportunity for me to learn. There's a Nobel laureate named Frank Wilczek who said, if you never make mistakes, you're not trying hard enough problems, and that's a mistake. So this means that you have the opportunity to kind of swallow hard and say, well, what's going on, and learn from it. In a similar way, like Cecilia was talking about with her advisor, there will be people who aren't necessarily as gentle with you as you would hope, but that you can still learn from them, so that you want them to give you constructive criticism and you get to absorb that criticism in the most productive way. That's kind of the bargain you have. As far as specific things to learn, nowadays it's very, very important to be able to do computer coding. Python is a real favorite these days in astronomy, and is also something that has big implications going beyond that. And something else I guess I would say is that as early as possible, try developing high-level reasoning skills so that you can figure out whether whatever answers you're getting are reasonable. And this is whatever topic you're doing. A lot of times, especially early on, you're given a problem set, you do the problem set. But the farther you go, the less well-defined the problems will be. And then you have to be able to say to yourself, does it make sense? So you do a problem, you get an answer that's 1,000 times the speed of light. Okay, something's wrong. You're supposed to get a length and you get something in kilograms. Something's wrong. And if you're able to develop this, not only is it a good way of checking whether you got the right answer, at least, did you definitely get the wrong answer, but you end up having a deeper understanding of things. So overall, especially at the stage of career most of you are, you're just learning stuff now, you're being told it, and you're kind of regurgitating it. But the more you can really think about it, to understand it, the better you'll learn it. And in my experience, at least, the more satisfying it will be.
And that's good for people skills as well. Reasoning in terms of people is this person someone that has maybe led you astray before? Is this someone a trustworthy person? And using those reasoning skills on people, not just, the science or math or whatever, is also a good skill to have. Navigating people, working with people. I would just want to add that.
Yeah, then that made me think about like your own scientific communication. Like, it turns out some of the best talks that I've seen folks give, and that's one of the high level things that we do is give talks. I mention it in my day to day, but I give a lot of talks. I've come across folks who've taken like, what's it called where you learn how to give a speech? You know what I'm talking about? Oh, I'm not remember the name of it, but it's like a popular thing across the country where you like go in the evenings and they teach you how to give a speech or public talk. Something like that would be also really great.
It can be scary. You can have an audience of people who know a lot of things, but the more you do it, the more comfortable you'll feel. And also the better you will understand the subject, because as you may have heard, teaching a subject is one of the very best ways of learning the subject.
Toastmasters, it's called Toastmasters.
Thank you so much for your advice. I know that since many students here are still figuring out what they want to do, it's really nice to hear that you don't need like a specific academic background and that you're allowed to make mistakes and still end up where you want. But yeah, so now that we've answered some of the questions from the RSVP form, we want to open it up to the participants. Please feel free to raise your hand using the Zoom feature, or if you want to unmute and ask a question, please do so. And you can also drop some of your questions in the chat. We will try to get through as many as possible.
Yeah, so we have our first question. So if you could either unmute yourself or just type into the chat what your question is.
Yep, Amelia, feel free to unmute yourself.
So, hi. My question is, so you've got a lot of experience in obviously physics, astrophysics, mainly because you study in university specifically for it. But let's say someone who can't really, who doesn't really have the opportunity to study in university, things like physics, or they would have to major in something else for any number of reasons, but still wants to study physics for their own enjoyment or just because they feel like it's a piece of knowledge that they'd really benefit from. What would you recommend for just like self-studying physics?
I'd recommend finding a going to a webpage at a university or whatever and finding a textbook that they use. There's a lot of great information out there on the internet, and there's also a lot of misinformation. And one of the nice things about studying at a university is you have professional folks who can help guide you through that process. So I would say like the language of physics is math. So if you can study math at your university, that gives you a fantastic background to be able to kind of jump into physics at any time. But I would say go and find a first year level textbook from a university and study that one yourself. Make sure you have the background. Does it require calculus? There's lots of great physics textbooks out there that don't require calculus, and then take those. There are decent textbooks online that are free as well. So if you kind of like investigate university recommendations, you can just read them and practice the problems on your own.
Especially do the problems. It's very easy to convince yourself by reading a physics textbook you understand things, but until you do the problems, you don't know.
Yeah, it's a little bit different from reading the public science books, the ones that talk about how the universe is big and beautiful and black holes and the Big Bang. And that's different from learning physics in college. But I agree, you could, or someone could take the textbooks and try to work it out chapter by chapter with problems and stuff. And not all textbooks work well for everyone. So if you get one that is not working, then you look for another one and you look for another one. And that's also true if you're actually taking the university class. Sometimes the textbook the professor is recommending doesn't really work for you, and you have to try to find another one.
Yeah, also depending where you are, it might be possible to do, let's say you choose, you're at a school that has, you know, math, but not physics, or maybe they have, this would probably be rare, but maybe they have some form of engineering, but not physics proper. You could also try, you know, looking for sort of summer internship programs that you could do dispersed throughout your other STEM related field as well. Like, I don't know if you're in the United States, NASA has a whole bunch of them, for example. And there's, you know, others in different parts of the world as well.
Yeah,
And also-
absolutely. NASA has internships for high school students.
Yes, and college students too. And I was just going to say, if you do have a degree, even if it's in something else, you can usually audit classes. And usually that's just a couple $100. I've done that at universities where I had the degree from, and I was interested in a topic, and it's just like $200, and you don't have to do the homework, but obviously if you're interested in learning the topic, you should do that too. And the teacher treats you like another student if you want to.
There's also a lot of online summer schools that happen these days as well. So like you would want to be careful that like, and some of them, you know, they're online, so you don't actually even have to pay. Again, I would caution to be make sure that what you found is from, you know, some reputable source. And a good way to do that is see that it's, you know, attached to a university or a research center or something like that. But there, yeah, these days you can find sort of like short courses, summer short courses. The International Astronomical Union has a really good one for undergraduates that happens all sorts of different places in the world, and it's funded, and you can go and do a short course in like astronomy, for example, even if your background is in, you know, something related like math or engineering.
Thank you for your answers. Does anybody else have any questions? Okay, we got a question in the chat. What do you think is something about astronomy that people do not talk enough about?
This is probably going to depend on our own specialties. I do work on black holes. I don't think people talk enough about neutron stars. Everyone has heard about black holes, not so much about neutron stars, but they're fascinating objects. They're extreme realms of physics all over the place, and it's something I've enjoyed studying for my entire career. But if you want to be a little less topic focused, here's something I'll mention that's come up a couple times in our discussion, and that is that human interactions are extremely important for you to do astronomy. It's not Dr. Frankenstein off of his Transylvanian castle sending papers to the Astrophysical Journal. You being able to go and talk to people at meetings and those sorts of interactions, they don't even have to be about astronomy. You can go on hikes together or play basketball or whatever. But that type of human interaction is important. And it's something that I think our society emphasizes things like the Big Bang Theory, where these people are all helpless geeks. But the most successful people you find are actually people who can be engaged with others.
I think that's good. I think also, I don't know if there's a lot of talk about how all the transferable skills you could do. Like we just talked about how it's some places you might not even be able to do a physics degree, let alone an astronomy degree. But there are also other places where you can do not a physics undergraduate, but an astronomy undergraduate. And so I would say, you know, there's a lot of transferable skills that you would get in a physics or an astronomy degree. And I don't think that's talked about a lot. And you could you know, you can go and learn about these fascinating things about the universe, and then you could actually leave astronomy at the end of your undergrad or your grad and then go make a bunch of money in a different area. And I don't think that's talked about too much, that people think about astronomy as somewhere to get you into like Silicon Valley or something like that.
I was going to say, if you're talking about astronomy, the only reason why maybe we understand what's happening or look at the other planets is how we look at our own planet. So a lot of studying other planets is based on studying the Earth and what happens here and trying to make comparisons and trying to understand. So a lot of technology is the same, and you'll hear anybody in planetary will talk about that Earth science and the study of the Earth is key to them understanding other planets. So I'll throw it out that.
Yeah, I think that for me is just basically how long everything related to space takes, from proposing a new mission concept to that thing being approved, to being built, to being out in space taking data, and then you're doing the science that you propose that you're going to do when you propose that mission. It could be, I mean, if it is 10 years, it's quick, right? So it's, and if you have something that needs to travel somewhere to then take the data, that takes even longer. So people in astronomy are always working with old technology because things take so long to be out there and taking data and being useful. So I think that the time scale is something that most people don't know about.
Yeah, I mean, James Webb Space Telescope, people worked on that for 20 years before it launched. And then, even once it launched, it's a while to get to the place where it's actually in a place to take data. And then there's commissioning time, which is making sure everything's working right. And of course, hopefully it'll stay up there 30 years and we'll get a lot of great information from it. But that means, that technology and also the time that people put into it a lot. I mean, my mission's an earth science mission and I've been on it for 7.5 years. So sometimes, we haven't even launched yet. We're launching in a year. So sometimes it can take a really long time for when a scientist has an idea and it's actually deemed ready to build it to actually when you launch and then when you actually get data that you can use.
Thank you for all of your answers. It was really interesting, especially to hear about how skills that you learn outside of your education can help you choose and benefit yourself in your career path. But yeah, we're going over the time limit. We are gonna have to wrap up now. Sorry if you had a question in the chat. But yeah, we would like to take a quick Zoom screenshot with our panelists and our attendees for a social media recap post. So if you'd like, please turn on your cameras now. Eileen will take 2 to 3 photos that we can get the best shot.
Awesome, thanks, Naga. Also, if you had other questions, we're going to share the panelists' contact information so you guys can reach out to them too. Oh yeah, that's perfect. Thanks, Dr. Louise Edwards. Okay, let me remove spotlight. Okay, if you guys want to, you can turn on your cameras. We're just gonna take a quick Zoom screenshot. All right, are you guys ready? Yeah. Okay, 3, 2, 1. 3, 2, 1. Okay, perfect. Thanks, guys. So now we'll be sharing the contact information for our panelists in case you guys had questions that we couldn't get to today or you think of further questions later. So feel free to take a screenshot of this slide and yeah, you can always reach out to these lovely panelists if you have additional questions in the future. Great. So now I'll just talk a little bit about how you guys can get involved with STEM to the Sky. So we have 4 main social media platforms, so Instagram and Twitter, where we release different content and also notify you guys of new interviews. There's also the YouTube channel where you can find all of our interviews as well as the recordings from our speaker panels. So once this panel ends, we will be uploading the recording to YouTube as well. And then we also have a LinkedIn, which you can follow. Everything is at STEM to the Sky. And if you guys have anything, any questions for us, you can always email us at STEM to the Sky. And then we also have a mailing list, which you can join at the bottom of our website, or you can also type your email into the chat right now if you'd like to be added to the list.
All right, thank you, Eileen, and also a very special thank you to our panelists, Dr. Edwards, Cole, Cecilia, and Beth Weinstein, for taking the time out of your very busy day to talk to us. It has been incredibly insightful to hear from all of you. And although personally, I never knew much about space and the space industry prior to this panel, it has been really interesting to hear, and my interest has been piqued in this field. I'm sure I'm going to be trying to stay more up to date on everything that's going on in the space industry, and I'm sure the rest of our audience was also just as interested as I was.
Definitely. We also wanted to thank everyone here for taking the time out of your day to attend this event. And thanks to Anaga and Sasha, who are the wonderful hosts for today's panel. You guys did a wonderful job. Again, if we couldn't get to your questions, please don't hesitate to reach out to any of the panelists. And we hope you enjoyed hearing from the panelists and gained some new insights. You can let us know your thoughts and suggestions about today's event using the feedback form that Sunghyun will post in the chat so that we can make our future events even better. And yeah, thank you again, and we can't wait to see you at future STEM to the Sky events.
If you have any additional questions or suggestions for STEM to the Sky, please feel free to stay behind for a few minutes and we'd love to chat with you. If not, please don't forget to fill out the feedback form. Thank you again, and we hope you have an amazing rest of the day or good night to those who are joining internationally. Bye, everyone.
Bye, guys. Thanks for coming.
Bye-bye.
Bye.
Bye.